Hello students, this is a paper discussion of ISS 2021 paper 4 section number B. In this we will be doing the demography and vital statistics. There are total 7 sections. Among them you need to do 2 sections. So I will be doing in each video all the section analysis. The first one is pretty direct. The hospital records and ad hoc surveys in relation to the vital statistic information. Remember that in vital statistics all these calculations are being done. So this you need to explain these two parts, and remember that the ad hoc survey is actually on requirement and punctuation basis. It's mostly done, and you need to show the basic relationship and interpersonal structurization as well. Okay, and remember that which one is much more important also we can do, and the trend analysis also is an important part. And remember that operating agencies also we can do it, and in the public administration based discussion also you can add, but don't just elongate it very much. So next one is discuss the internal migration, rural urban migration and international migration. Pretty easy. So what is this internal migration? Internal migration means within a country, within a space, like from A to part B. Rural urban for where it's actually happens for the wage differences. Wage differences happen between the educated and uneducated people of the rural and urban zone. Urban is the city or developed, and rural is the mostly villages. So wages in urban area is higher than wages in the rural area. So wage, and sometimes there is not enough job available, so that is also a reason of rural urban migration. And until and unless this inequality is maintained, the migration happen. There is also another thing which they didn't give in the question. That's called a reverse migration, where people from the rural urban area go to the rural area for job. For example, in sometimes I have seen it in trains, like when I'm returning from some places. Okay. And at that time I see there is a reverse crowd. For example, at the daytime, if you see from Kolkata, Mumbai or New Delhi, so in the trains from in the morning time, suburban area to the urban area, when they are coming, they are filled up. Okay, and at the evening time, when exactly these people are getting back home, so they are filled up. So what in my case, in those days when I was doing special research based work, so in the morning time I used to go to the rural area. So this was, so all the time the trains were almost empty, and when I was returning in the evening, I saw those filled up trains and my trains are completely empty. So in that case, so this is a perfect case of a reverse migration with respect to the number of people. So yeah, a lot of people from cities also go to village areas, mostly government jobs, teachers who teach at the government colleges, schools, they do this reverse migration. And another is international migration from country A to country B. So country wise, so there are some hard and fast rules. You need to compare the rules. So for the internal migration, rules are very less. Rural migration, there is a little bit more, but international migration, the rules are really hard. So at the time of the coronavirus attack, so there's been a lot of problems around for this. Many of the people, they can't go and do their jobs at these places. So this is a real big problem for rural, urban, and international migration. But with respect to internal migration, this problem is relatively tackled. Okay. Fecundity and fertility. So what is the meaning of fecundity? So fecundity, let me just explain the term. So this is the ability to produce an abundance. Okay, abundance of offspring or new growth. Okay, so this is a type of, so how quickly they can do it. So fecundity, so this is very close to fertility, but they are not same. Okay, they are not same, and mention the various measures of fertility. Also discuss the relative merits and demerits of it. So we can put it like that, let me just add up a page over here so it will be easier for me. And okay, for example, if I talk about fertility and if I talk about fecundity, So fertility is nothing but the normal, natural ability of an organism to reproduce, natural ability to reproduce. But fecundity is the potential, this is the potential of an organism or a population to reproduce. Okay, so this is the one is potential and one is ability. In this case, number of offspring produced by, so the measurement is being simply done by total production, by a mating couple. That's it. But here, number of gametes or seeds produced. Okay, so this is very important. The main determining factor here is nutrition, endocrine patterns, or socio-economic pattern, behavioral pattern, these kind of stuff. So how much they're inclined towards reproduction. The social stigma is that whether the country is controlling, like China, the second child is their tax increases. So there's been a lot of restrictions. So here mostly environmental factor plus genetic factors. Okay. Another one, the concept defining lack of fertility here is the concept of infertility. And here the concept is called sterility. So they can't produce. So pretty close but not the same. Okay. Now let's get back to the old page. First part done. So mention the various measures of fertility. Yes, there are various measures which we can apply. For example, one is CBR, full form is crude birth rate. Then is GFR, which one says general fertility rate. There is TFR, total fertility rate. This you can do. So mention the various and also discuss the relative merits and demerits we can do. You can go for the calculation of it as well. So let me just give you a small idea on the basis of the calculations of these things. So this CBR is nothing but the total number of children, born in a year, divided by mid-year population, this thing into 1000. This is a very direct process, but age, sex, these are the things are not being taken into consideration. It is expressed as the terms of the number of births in a year per 1000 of mid-year population. So these are calculations. So it doesn't specify why birth rates are different in different years. Why it's different in different years. So this answer you won't get. And between the different populations in the same time. So this has not been given. So GFR, so after crude birth rate comes the general fertility rate. So the fertility we are talking about right now. So this GFR is also important. For now the GFR is actually b to the power t summation of f into px into k. This is the formula actually. Bt is nothing but the number of live births occurring among the population. This is the live births among the population of a given geographic area during the period t. Okay, summation of f into px, where this is from lambda 1 to lambda 2. So these are two things. So female population in the reproductive age. So this is the female population in their reproductive RP age. Okay, in this geographical region during the time t, and lambda 1, lambda 2. So lambda 1 is the lower or upper, lambda 1 and lambda 2 are the lower and upper limits of the female childbearing age. Age limits. Okay, and this k is a constant. Usually we can put it like 1,000 as well. Okay, in every 1,000 people. So the fertility rate may be defined as the number of babies per 1,000 women in the reproductive age group. So there are some merits of it. So generally GFR is like probability rate. So this can determine the upcoming time, and GFR reflects the extent also. But demerits is heterogeneous figure since it overlooks the age composition. It doesn't take of the female production of the child, hence it suffers from the drawback of non-comparability with respect to time and country. So non-comparability issue. This is a big issue. So this they are facing, and also the as two populations with altogether different GFR may have same fertility in each country. So 2 GFR yet same fertility. So we just can't say the particular things, or we can't be so sure about the answers. So this is very important. Okay. Another one is there are other fertility TFR I talked. So I missed out one thing over there. So that is called SFR is also there. Okay, specific fertility rate. Let me just add up a page. So SFR or specific fertility rate is also there, like number of births of female population of the specified section, female in the section, divided by number of female population in the specified section into 1,000. So this one is a pretty direct, and the one which I was talking about, the TFR. So this is also a very good nice formula, that is summation of lambda 1 again lambda 2 and capital BX F into PX into K. So K is in general 1,000, and here IX is defined in the same way before. So you can just put it that so this is the beta X is number of births of the female in the age group of from like X to X plus N, in that way. In a particular age group, like here X in age specific, if they do it, so from a particular two age groups have been given, and the summation of F into Px is not the nothing but the average female population into that. So this is the TFR. Okay, so usually lambda 1 is 15 and lambda 2 is 49. Okay, so from 15 to 49 is the productive age is to be taken. Okay, so for example we can talk about that, like the TFR is nothing but a hypothetical figure also, and they also take that none of them lives before 49. So they all living till 14. There may be accident, there can be deaths from other diseases as well. Okay, so if the number of women at each age is decreasing, and these all are becoming very important. So this is the answer to this question. I went a little bit long, but this was needed because vital statistics related informations are not that easily available. So the next is given the complete expectations of life at age 25 and 26 for a specific group of these two, the number of people living at 25, this find the number that attains age 26. The next one is a direct life expectancy based problem. So you can just put it into the formula and do it. I will do it in the elaborate solution based section again. Next is describe intercensal and post-censal estimates of the population growth, assuming the linear growth and exponential growth in the mathematical method. So pretty easy. So this one, intercensal estimates are calculated using the data which is beginning and end years are reported, and post-censal estimates are calculated using the data only the beginning. So only beginning and end. So post-censal is actually less informative, and the first one is more informative. So and linear and exponential growth both based structures have been they have asked. There are some natural increase like birth, death, internal migration or interprovincial migration. So these are the basic reasons of this thing. There are some sources of it, like base population, birth, immigration, emigration. So these are the pattern, and we can just here also and explain in a little bit of mathematical way. So P of t plus I equal to pt plus b t comma t plus I minus d t comma t plus I plus I t comma t plus I minus e of t comma t plus I plus delta t e t comma t plus I. This is done, plus r e t comma t plus I plus delta npr tt plus I plus delta n and tt plus I. So this is the whole thing. So each province and the territory wise we can see. So this is the interval between the two time t and t plus I. Okay. P of t plus I is the estimate of the population at the time. This is the estimate of the population at the time t, and this is also the base population as well. B equal to birth, D equal to obviously death, I equal to immigrants. E for emigrants, delta T is net temporary immigration. Net temporary immigration. RE means returning immigrants. So people, they come to A to B, so they are now, this is immigration, so they get out, so this is emigration, and they are coming back again to B, so returning immigrants. NPR, net non-permanent residents. Net non-permanent residents. Okay, and delta N is net inter-provincial migration. Net inter-provincial migration. Okay, so this can be done with respect to age and sex as well. So there is a lot of calculations are involved, and remember that intercensual population estimates, we can do it. For example, we can take this equation, p minus p dash. This is the error of closure, this is the post-censual population estimate, and this is the census population after adjustment for CNU. Okay. So these are like basic structure. So with respect to the post-censual structure, mostly intercensual estimates are considered to be more accurate than the post-censual estimates because of the approximation between the two dates and the exact figure. Okay, so there have been a lot of survey and country-wise statistical surveyings are being done. Okay, like Japan releases a regular annual incremental done with respect to cities in every October month. Okay, so these are the facts here. Next is, this is done. Let me just clear the page. Now, after first four, write a critical note on the salient features of the Indian censuses of 1991 and 2001. So this is a pretty much direct theory. You can see it in my complete notes. There is a comparison-based analysis, the more and more improved technique, and more people also got involved into this, like 100. These are the extra things you need to provide and try to give an elaborate answer. Explain Pearl and Reed method of fitting logistic curve to the population projection. So this one is a pretty interesting stuff. Firstly, done a long time back. So there are some assumptions of this curve. Let me just give you a brief intro of it. So first is population grows in the finite area, and the rate of population growth cannot be infinite, growth not equal to infinity, and the lower limit of the population is not 0. So the population does not start with 0, lower limit not equal to 0. And yes, the point of maximum rate of growth is the point of inflection. So point of inflection means this thing, where concave to convex or convex to convex. So the point of inflection of the population growth. So point max growth point equal to point of inflection. So expansion of the curve, the derivation, so this thing is pretty easy. And with respect to time period, I'm just giving you a basic formation only. It looks like this for a particular case, like x1, maybe then this is x2 will be here, then x3, and then x4 in this case. So like q1, q2, q3, q4, q5, q6. In that way this has been done. The main thing about the curve, if you want, the mathematical formation which they asked in the question. So the growth of population in an area of fixed limit has this following. So the point of inflection is the same point at x equal to alpha and y equal to beta. We'll be using this very soon. And an asymptotic to a line y equal to k and x equal to plus infinity, and y equal to 0 and x equal to minus infinity. It is asymptotic towards this as well. And no horizontal slope concept. An equation which fulfills this requirement is y equal to b into e to the power ax, 1 plus c into e to the power ax, where a comma b comma c is positive. The above equation we can also rewrite as in this way: y equal to k y plus e to the power d minus at, where k equal to b by c and c equal to e to the power d as well. So where t is rather than x determines, so this is denotes time. So you can do it with respect to dy dt, k into a e to the power d minus at, and I this is the square. So in this way, the formation analysis, you can get it in any standard books or you can see it in my notes. So the main structure of this, there are been very amendments have been done with respect to American organizations. There has been a British amendments also there. There's a German and amendments have been done into this formula. So every country, according to their own structure, they changes this population projection part. Okay, next calculate is a direct question: GFR, SFR, TFR, and GRR. So this already I have shown before. So pretty direct formula only. You can put it into this and get the value. Okay, so only one thing I haven't provided: the gross reproduction rate, GRR, is summation of ASFR F dash into 5. Okay, so we did multiply by 1000 because the results involve women, not per 1000 women. Okay, so this is it for that part. And we can calculate this pretty easy. Okay, we can choose to solve this question as well. So let me just add a page. Okay, the first one is the data. So the ages are 15 to 19, 20 to 24, 25 to 29, 30 to 34, 35 to 39, 40 to 44, and 45 to 49. A number of women, it was given that 16, 16.4, 15.8, 15.2, 14.8, 15 and 14.5. And number of births is also being provided. Birth is 260, 2244, 1894, 1320, 916. So with rate age, this is falling. Perfect data. So age specific fertility rate, ASFR. So we can calculate that here. So first of all, GFR we need to calculate. GFR, so which is nothing but the first part of the question. Just let me have a look whether they have given the GFR or not, otherwise it will be a wastage of time. Yes, GFR, general fertility, specific fertility, total fertility, and gross reproduction rate. The last one will be a little bit hard. So GFR is summation of NBX by summation of N of f of px into 1000. So this is the first value. So here we need to calculate this. So this will give you 7059. This is giving 107.7. So this is pretty easy. So 7059, and remember that this whole thing is in millions. So 107700. So this into 1000. These two cancels out. So this will give you 60.543 per 1000. This is the first part done. With respect to the second part, SFR calculation. So this is nothing but 260 divided by 16 into 1000. Okay, 260 divided by 16 into 1000. So this value, so normally we just not putting that 1000, so I'm just putting 16.25 here. This will be the value for our calculation. So 16.25. The next one is 136.83. So I've already calculated, so I'm just putting it already. So 86.84, 61.89, 18.67 and 10. If you just add them, it will be 450.35. So in the second part of the question, so the SFR, specific fertility rate, so here it will be the table itself. So this is the thing. Next, the summation will need it later. TFR, total fertility rate, is 5 into summation of NIX. So that is 5 into this value, 450.35. So this is 2251.75 per 1000. Last one is gross reproduction rate. So in this case we cannot compute GRR by formula, since we are not given the group wise breakup of the birth rate. So group wise breakup not given. However, since it is given that the production of female birth is 46.2%, this is given in the question. So we can obtain the GRR by the approximate formula. So this is GRR is equal to 46.2 by 100 into 2251.75, which is the TFR we have calculated here. So this will give you 1040.31. So that's it. That is the full question's answer. Okay. Okay, we have the last one left. Fill in the blanks with the following table marked in the question. Ages have been given and we need to find it out. Okay, this one is a pretty interesting one. Let me just give you a short analysis of it. For example, this actually LX here is 693435 and LX plus 1 is our 690673. Okay, so the dx, the first value is, so obviously this you don't need to calculate. So these are 1, 2, 3, 5 questions. These will now be like 5 marks. So dx is equal to lx, L of x plus 1. So 693435 minus 690673. Okay, So let me just explain. So with respect to the upcoming age, what is happening? So this is the life table based thing. So 693435 minus 690 673. So this will give you 2762. So the first one is 2762. Next one is the QX. QX is actually dx by lx. Dx by lx. So this is dx and this is lx. So 2762 by 693435. So this is 0.003983. After QX is been done, we are end up with the PX thing. So PX is 1 minus QX. Okay, so this is 0.99601. Okay. So here it is taking the full calculation I have done. So in the given calculation 0.003983 I have taken. So this will be 996017. Okay. So this is the QX value, which is nothing but L of x plus 1 by Lx as well. Next one is anything else? Yes, there is e of x to the power 0 is already given. So this will help us to find out the other parts as well. For example, e of x to the power 0. So there is a relationship ex equal to ex0 minus half. Okay, so ex equal to e of x to the power 0, which is given 350,81126 minus 0.5. Okay, so this is 350,81125.5. So this is the calculation here, and this is nothing but let me see, this is Lx. Yeah, so Lx is small lx is the first part, capital Lx is minus half of dx, or this can also be written as half of Lx plus L of x plus 1. Both the values have been given, Lx and L of x plus 1, so you can just put it and find this answer as well. So that's it for this vital statistics paper. In the next part we'll do it the section C.